We are looking at the toolset for problem solving, and in particular, we are looking at the universal approach to problem solving. The very fact that it's a universal approach makes it a very generic approach that can be applied to any kind of problem. Now, I'm going to give you a magic formula of how to solve any problem. Yeah? Are you all excited about it? Yeah? Okay. Yeah. Yes, yeah, any maths problem. Yeah. All right. So the generic approach of problem solving is when you're given a question, typically in your junior math challenge or Olympiad, the question will have lot of information in a very clouded way. It will not be cleanly defined. You'll not be able to you'll not see only the information. Information will be embedded in a long sentences in words. Yeah, it's an art to extract out that information. The information given to you will be in a very cloudy fashion. Yeah, this cloud represents a bit vagueness. So what you have to do is basically draw out the relevant information. Just cut out all the jargon, cut out all the unwanted stuff, and just pick out the right information. You have to actually find the right information in the question. And it's much easier if you can draw a diagram or a table based on this information. You If the question is given, if you see these tables, even without reading it, and this diagrams make it much easier understanding of the information rather than big paragraph of long questions. Yeah, you'll agree that this representation of information is much better than the long sentences that you're given. So the first step you have to do is basically draw out the information and put it into something which your eyes can very easily see. And information is apparent to you, it's obvious to you. All right. Okay. Now, once you have done this, you the solution step the solution you can start on your journey to solve. And in order to do that, you have to find a starting point using the information given here. You need to find a starting point for your solution. And from the starting point, you'll take a few steps till you reach your objective. Your objective is what question is being asked. Yeah, so you'll have to find some starting point and follow some steps to reach this objective. All right. In all these steps, you will be using the information which is in front of you. And in some of the steps will basically you'll augment the information into your diagram or table. All right. Don't worry. Don't have to take it literally. We'll see lots and lots of examples. We'll solve lots and lots of problems in using this approach. So just try to understand what I'm saying. Okay. So the information has to be extracted, and only the relevant information should be used. The best way is to draw a table or diagram like this. Then you have a starting point. You find a starting point. How to find the starting point, we'll see in a lot of examples. From that starting point, you'll have to take a few steps till you reach your objective, which is to answer the question. In this journey from starting point to your objective, you'll use the information which is given here. All right. Now, more often than not, the journey from your starting point to your objective will not be smooth, will not be very straightforward. You are bound to face some hurdles. You're bound to face some problems. Yeah. And these hurdles can be either in the middle, in after doing some steps, or it may be at the very beginning, or it may be at the very last step. Yeah. When I say hurdle, it could be anywhere in this journey. And this hurdle will be such that all the information that is given to you is not helpful in progressing it further. That's what this brick wall means. You've used all this information, but you're not able to move forward to answer the question. Whenever you face this situation wherein all the information given here is not helping you in achieving your objective, it means it's time to make an assumption. You have to make an assumption. You don't have to be shy of making an assumption, because assumption will let you jump over skip over this wall and carry on with your journey. So making an assumption is a very very important thing, and a very very important step in crossing over the hurdles that you'll see. Yeah. Now, the assumption will give you this letter, or it will help allow you in overcoming this. Now in many questions, sometimes it's much easier to go from the objective, just like in your in your multiple choice question, if you look at the five options, yeah, it's easier to solve it backwards by looking at the option and trying to figure out whether it is answering the right question or not. Yeah, so some in some of the cases the journey will be backward rather than starting in the forward direction. You start and look at the options and go backward and see whether it is matching with what the information is given. Now, what we learned about the generic approach to problem solving seems very theoretic, isn't it? It sounds all right. Probably it makes sense, but I'm not sure whether it can be applied or not. So let's look at an example and apply the generic approach to problem solving and see how effective it is. Is it really effective? And if yes, how effective it is. So the first step that you get in the generic approach to problem solving is you get a question in which a lot of information is given in a verbose manner, long English sentences, very big paragraphs, and so we looked at the generic approach to problem solving, and it seems all right. It seems very theoretical. We have not seen the application of it, so you may be thinking as to how applicable it is. And the very fact that I'm claiming that is a generic approach, universally applicable, I'm sure you must be having some doubts. So let's use this generic approach of problem to problem solving in actually solving a very difficult problem, a problem which seems very difficult, and see how effective it is and how it can be applied. So, in the very beginning, the question given to you is in the form of a clouded information. Long sentences, big paragraphs, lot of jargon, lot of words, um, uh, uh, and the question, the objective, and the information given is very clouded. The very first step that you do is basically extract what is the objective. Highlight the objective that you want to achieve. What is the outcome that you want to reach? Let's look at an example. So Rahul runs twice as fast as he walks. On Monday, when going to school, he walked for twice the time for which he ran. On Tuesday, during doing the same journey, he ran for twice the time that he walked and was 6 minutes quicker than on Monday. And on Wednesday, he walked all the way to school. How long did this take him? So if you see here, it's a very long worded sentence. A lot of information is given. On Monday, Tuesday, and Wednesday, he's walking sometimes, he's running sometimes, and uh, the speed of walking is half the speed of running. A lot of information is given. Yeah, so that makes it very complex question. So we'll apply the generic approach of problem solving and see and do it in a step-by-step fashion. So the very first thing is to find the objective. Yeah. So the objective here is on Wednesday, how long did it take him to reach the school? So on Wednesday, in how many minutes or in how many hours did he reach the school? So this is what your objective is. Now, uh, uh, the next thing that you do is basically all the irrelevant information, all those cloudy information which is given in the question, which makes it very complex. You'll try to, cut the clutter. You'll try to remove the chaff and extract the relevant information and put it into either a table or a diagram. Yeah, we'll come to the table in this particular example. We'll come to the table after some time. Let's focus on the diagram. Let's convert the information which is given to you into a nice looking diagram. And as they say, picture is worth 1,000 words, and see how irrelevant it is. Now, we'll draw a diagram. Basically, on each of the 3 days, Monday, Tuesday, and Wednesday, Rahul is taking a journey from his house to his school, and there are two modes in which he travels. The first is the walking, and the second is running. Now, it's not necessary that he'll be walking on each of the 3 days or running on the each of the 3 days, but essentially he has got two modes of travel: walking and running. Now, as soon as you make this diagram, it gives you an insight. As the beauty about of making of translating this question or this information into a diagram is you start seeing some of the things which is not so visible by looking at these long English sentences. The very fact that the distance between house and the school is the same, irrespective of whether it's Monday, Tuesday, or Wednesday. He's taking the same journey on Monday, Tuesday, and Wednesday. So that gives you an insight that the distance traveled is the same on all the 3 days. Yeah. Now, it may sound a very complex problem, but just to reveal, basically, there is only one piece of theoretical knowledge that you need to solve it. There is only one piece of theoretical knowledge which is applicable in solving this problem, and that is the fact that distance is equal to speed into time. This is all the theory that you need to know in solving this problem. The distance is speed times time. Yeah, and the fact that the distance traveled on all the 3 days is the same. So this distance, after which is calculated by speed into time, will be the same for Monday, Tuesday, and Wednesday. So now we have from the clouded information, we have identified the objective, we have translated into a diagram. The very moment we converted into diagram, it threw some insight which is helpful. And so now we'll start using this information, the insight that we have obtained, in our solution journey from our starting point to the objective. Yeah. Now, how do you find the starting point? The starting point, as we know, is the starting point is the easiest value that you can put that you can extract based on the information given to you. Yeah. Now, so starting point is something on which you can build your solution upon. This will be the first step, the very first step in your journey, solution journey, towards your objective. Now, in this question, if you notice that you're supposed to find the time it took in minutes or hour on Wednesday. Apart from it, no other information is given in terms of value. Yeah, we don't know the speed at which Rahul walks, or we also don't know the speed at which he runs. We all that we know is that the speed of running is twice that of walking. We also don't know how much of distance does he cover between school to house, from house to school. We don't know how long it takes on each of the 3 days. So basically, all of it is unknown. There's nothing known about any of these three variables: distance, speed, and time is not given to you. Yeah, which means in your solution journey from starting point to objective, you don't you get stuck at the very first step. You don't even have a starting point from which you can build upon. Yeah, and you're stuck at the very first step. We are hitting the brick wall in the very beginning, which is to identify the starting point. Now, as the generic approach says, you when you get to hit a brick wall, you overcome it by making an assumption. So we'll make an assumption. Let's see how assumption helps you in progressing. So in order to make the assumption, we'll use the fact that Rahul runs twice as fast as he walks. Now what it means is, if the speed at which Rahul walks is v meters per second, which means he travels at a speed of v meters per second while walking. Yeah, which is what is denoted here. V is the speed here for walking. Then the speed at which he'll be running will be 2v meters per second, just twice the speed of walking. Yeah, now that gives you a useful kick in your journey, kickstart in your journey towards our objective. So now, as we said, we have so 2v will be the speed at which he'll be running. Now we have drawn the diagram. Now let's come to the table. Let's make a table so basically what you have done here is basically you have overcome the brick wall by making an assumption, and now you'll progress in your direction to your objective. And in all the steps, basically you'll be extracting some information from the diagram or the table, and also updating the information in the diagram and table. So we have talked about the diagram. We have drawn the diagram. Let's make a table now. Let's make a table. The table looks like this. The journey on each day comprises of two components, the walking component and the running component, and this column denotes the total. So so this total is basically the sum of the walking part and the running part. And we'll consider in the rows, we'll consider all the 3 days on Monday, Tuesday, and Wednesday. Yeah. And now we know that this the theory part says that distance is speed into time. Speed we have assumed as v and 2v. Yeah. So let's track the distance and time for the walking, running, and total on each of the 3 days. Yeah. So the total here means, the time taken for walking plus the time taken for running will be the total time taken for the journey on all the 3 days. Similarly, the distance covered in the walking plus the distance covered in the running will be the total distance between your house and school. Now, Uh, again, as we know that out of the three variables, we only have assumed, we don't even know the value, we have only assumed the speed to be v and 2v. We don't know the distance and the time. Yeah, so which means you're stuck again at this point. So you'll have to make another assumption. The other assumption that you'll make it is that let's assume that the time taken to reach the school is as given in the table below. Yeah, so we'll assume that the time taken on Monday, the time taken on Monday, the total time taken on the Monday is 3a. Why we are assuming it as 3a? Because it is given that on Monday when going to the school, he walked for twice the time for which he ran. So if he had ran for a minutes, then he would have walked for 2a minutes. The time for which he walked is twice the amount of time he took for running. So 2a plus a gives you 3a. So that's why we are assuming the total time taken on Monday is 3a. Likewise, the total time taken on Tuesday, let's assume it as 3b. Why we are taking it as 3b? Because the information given here is on Tuesday, doing the same journey, he ran for twice the time he walked. So on Tuesday, if he had if he had walked for b minutes, he would have run for twice that time. So he would have run for 2b minutes. So b plus 2b gives you total 3b. Not just that, on Tuesday we also know some additional information. The additional information is that he was 6 minutes quicker on Monday, which means the difference between the time taken on Monday, the total time taken on Monday, and the total time taken on Tuesday is 6 minutes. In fact, on Monday he would have taken 6 minutes more than the time taken on Tuesday. So that gives you an equation. That gives you an equation that 3a minus 3b is equal to 6. The time taken on Monday minus the time taken on Tuesday is 6 minutes. Okay. Uh, so we'll mark it as equation 1. Now, then finally, we'll come to the Wednesday and we'll assume that the time taken on Wednesday is t. Why is it t? Because the information given here is on Wednesday he walked all the way to school, which means he just walked for t minutes and he did not run at all. So the time for running is 0. He didn't run at all. So t plus 0 gives you t. Now, so if you notice what you are doing here is basically we are updating the table. We are updating the information as we are trying to fill in this table, which is essentially taking further steps in the direction towards your objective. And in each of the steps, we are also updating this table. We are also updating this table. Okay. So we have come to this point. So we have taken care of all the time components. Now let's look at the distance component. In order to fill in the distance component, we have to use the only piece of theory that you need to know for solving this problem. And that is that distance is speed times time. Yeah. So if you're supposed to find the distance covered by Rahul on Monday while walking, that distance will be just speed times time. So this V and 2a will be multiplied together to give the total distance, which is 2ab. Likewise, on Tuesday, the distance covered will be V times B, which is PV. And the distance covered on Wednesday is V times T, which is VT. Likewise, if you come to the running component, The distance covered on Monday running will be 2v times a, which gives you 2av, and 2v times 2b is giving you 4bv, which is the distance covered while running on Tuesday. And finally the distance covered while running on Wednesday is 0, because he's just walking to the school on Wednesday. He's not running at all. Yeah. So we have taken the individual components. We know the distance covered walking on the 3 days, distance covered running on the 3 days. Now we'll find the total distance covered on each of the 3 days. So the total distance covered on Monday is going to be the sum of the distance covered walking plus the distance covered running, which gives you 4av. Likewise, the total distance covered on Tuesday is going to be bv plus 4bv, that gives you 5bv. And likewise, the total distance covered on Wednesday is tv plus 0, that gives you tv. Now, so we have filled all this, all the missing components in the table. So the information that we have is complete now, in the sense there is no missing block which is here. So we'll try and progress it further using the fact that the distance traveled on all the 3 days is the same. Yeah, the distance traveled on each of the 3 days is the same, which means the total distance here, 4a v, 5bv and tv, are all equal. They are all equal to each other, which means you can get another equation, just like got the first equation, you get another equation, which is by equating 4a this t with 5b with 4a. This is the second equation. We are cancelling out the v part, so you get t is equal to 5b is equal to 4a. Now from this equation, you know that the first equation relates a and b, the second equation also relates a and b. Let's try to find the value of a in terms of b, so that it can be substituted here and we can solve it. Yeah, how to solve the equation is something which you'll will not cover here, but essentially it is by substitution method. So the substitution method, in order to find to do the substitution, will express a can be written as 5b divided by 4, and this can be substituted back into this one. Once you substitute it, you can solve it for a and then derive the value of b. We are not going into how to solve simple equations. That's something which you'll be getting familiar with separately. So if you solve it, you will get a is equal to 10 and b is equal to 8. Yeah, if you solve this two simultaneous equation together, you'll get a is 10, b is equal to 8. And so in this equation 2, if you substitute a is equal to 10, your t will be 40. T will be 40. Or if you substitute b as 8, 5 times 8 is again going to give you 40. Now what is t? T is the time he has taken on Wednesday. On Wednesday, that is the total time taken by him, which is what your objective is. Your objective was to find how long did it take him on Wednesday, and that is 40 minutes. So if you see, we have extracted the information into a nice diagram that gave us the insight. The insight was useful in terms of making progress from your in your solution journey. We got stuck at the very starting point because we didn't have sufficient information in numeric terms. So we made an assumption at the very beginning, and that helped us in progressing further in your journey towards your objective. And all the while, basically, we were extracting the information from the diagram and the table, and also updating the table. Yeah, and this helped us in a step-by-step fashion to fill in all the all the cells in the table, and you got some equations on the way. You solve those equations and meet your objective.
You have just seen a free sample video in which just one of the many tools in our problem-solving toolkit was practically applied to solve just one very difficult problem. To get even more benefit, please also have a look at the other videos available on a variety of problem-solving tools offered to you in our toolset. However, just watching these sample videos is like just glancing at the tip of an iceberg, whilst much more remains unexplored. It's like only watching the entrance of a gold mine without entering it, when the entire gold mine is available to you up for grabs. If you want your child to become proficient in solving hundreds of the toughest problems that any child in their age group will ever solve, anywhere on the globe, if you want these techniques, the entire problem-solving toolset to become a natural instinct, then please sign up with YoungThinks. YoungThinks courses are available according to age group and will expose your young thinker to hundreds of such problems, till a point comes when these tools become an inseparable part of their brain's DNA, something that they will invoke automatically and unconsciously when they face a problem. For a moment, think of the mental and intellectual transformation brought about by such a course in your child. Think of the confidence your child will possess once they internalize the full Thinking Skills Toolkit. Visualize the attitude with which your child will approach their studies at school, including any subjects that they may find difficult at the moment. Think of the kind of adult your child will grow into, fully equipped with the Thinking Skills Toolkit. What kind of professional achievements can an individual who has the mindset of a problem solver reach? And to put it in a very crass way, what kind of earnings this individual who knows how to think and solve any problem will make? The success, once you achieve it as a problem solver, is not just restricted to maths or physics or subjects in your studies. It percolates to all walks of life. It makes you a well-rounded, confident, and complete individual. The fact that no school in the country, no tutor in the country offers it, makes YoungThinks courses a unique skill set to acquire. Now you may be wondering, who all have benefited from this course? The beneficiaries include 1. Child Genius National Finalists, 2. Prize and medal winners at National Maths Olympiad, 3. Children with IQs at par or above Einstein and Stephen Hawking, 4. Invitees of special summer camps at Oxford and Leeds universities, 5. National Team Maths Championship finalists, 6. Aspirants appearing in the entrance test to the best universities in the UK, including Oxford and Cambridge, 7. Achievers with the highest grades in GCSE exams. So don't hesitate. Register for the YoungThinks courses starting very soon and let your child make the most of them. To register, go to www.youngthinks.co.uk and click the shop page to find the full range of courses suitable for your child's age group. If you have any queries regarding the course, the registration, or the discounts available, it's best to give a WhatsApp call to the number appearing on your screen, or send an email to the address given here. Please do not hesitate to contact us and get the best possible advice. After all, the right course may transform your child's thinking and problem-solving abilities to a height that you can only imagine. Do not wait another day. Book your place before the registration closes, or contact us to discuss what is best for your child. We will advise you on the best options for you and your child, depending on your unique context.